Go to what we have for today. How do we graph a function like in number 5? So the first thing we want to do is make a table of value. Make a table of value for each piece of the function. So I'm going to make a table here. I already see that the first piece is a linear function with the coefficient of x as 1. In other words, the slope is 1. I want to say because the slope is 1, it is rising to the right. And I am told that the condition has to be less than or equal to 5. Conditions matter a lot in piecewise defined functions. So it means that you cannot exceed this condition. So I can start from 0. I can just say 0. I know that 2 points make a line. 0 is included. So when x is 0, y, what is y? So I'll just put in f of 0. Let me come here and put f of 0. So f of 0 in the first piece is going to give me 0 minus 3. Therefore, f of 0 is minus 3. Okay, so this is f of x. Okay, and I want to pick another point. I just need to, because it's a line, I can only use 2 points. So I know that 5 is included, so I'm going to put 5. So f of 5, I will plug into the equation the piece, the first piece. So I have 5 minus 3 gives me 2. So I'm ready to graph the first piece. So if I actually make the points, so the first point is going to be 0, negative 3. The second point will be 5, 2. So I can grab this point and draw the graph. I want to make sure I remember that the condition, the inequality is closed. 5 is included. So I will sketch. I'm just making a sketch. And when I finish sketching, I'll choose the one that fits. I will choose from here. Okay, so let me make my own sketch and see how so I'm just going to make a sketch. I will just make a sketch here, draw the first piece. Okay, the first point is 0, negative 3. So 0, negative 3 is supposed to be somewhere here. And the next point is 5, 2. And 5, 2 is somewhere here. And I know that this is a line with a positive slope. So I know that it's increasing. So it's increasing to the right. Increasing to the right. So this piece of function, I want you to see that this is closed. Everybody see, this is closed. Okay, and the point starts from 0, negative 5 to, so it means that the first point is included. Now, I will eyeball the graph here and see which one. Is there anyone? Because I can actually stop here. Is anyone looking like mine? Okay, which one looks like mine? I already see that the one that looks like mine is D, but I'm going to complete the, I will complete the graph. So I'll make another table of value. The other table of value is x is greater than 5. So this is x. This is f of x. All right. It tells me that this line is a constant. So since it's a constant, at any point it is from 5, x greater than 5. So 5 is not included, but I'm going to put 5 here. 5. And there is nothing here. If I put 2 here, I'll know this is open. But I can put 2 here so that I can show you. 6. It's going to be 2 because it's a constant. So I can quickly know if it is 5 here. And when it is 5, it is 2. So the graph is going to, let's see how it's going to look. Let's see how that is going to look. So 5, 2, and we see that it's a constant. It's greater than or equal to 5. It should be pointing to the right. Should be pointing to the right. And I'm looking for the one pointing to the right. Actually, this mine here, though. So it should be pointing to the right. It's a constant. So I greater, less than or equal to, this one should be facing this way. Facing this way. So I want to redraw this one, say we're facing to the left. Let me redraw this. Because that's supposed to be less than or equal to. Okay. So I have less than or equal to, so it should be actually going this way. And then the 2 is, the other one is going to the right. So it's going to be 2, 2, 2 from here. It's going to be to the right from 5 here. So 5, 2, 6, 2, and it's open. It's an opening here and goes to the right. So let me see if I have a graph that looks like this. So actually, this is the one that instead of this. So that's the one that has and then we can look it up later on. You can actually use your calculator to graph this, but you can use your calculator to graph that and check. So the same thing goes here. You will make 2 tables of values and you make a sketch. So if we make 2 tables of values here, for the first one, x is less than or equal to 1, so the graph has to be going to the left. So this is x, this is f of x. When x is less than or equal to 1 means that it can be 0, it can be 1, and this is enough for me. All right, so, and it's less than or equal to, so the arrow will be going to the left. Okay, when x is 0, f of 0 on the first piece, I have -2 minus 0 is -2. And f of 1, -2 plus 2 times 1 is going to give me 0. So f of 1 will give me 0. So then you plot the points, you will plot this point. And these 2 points, the first point is 0, -2. The second point is, the first point is 0, -2. Second point is 1, 0. And you plot the points, connect the first term. This is the first piece of equation, and that's the condition. You do the same thing for the second equation. Okay, and you go ahead and choose which one. So let's put it in our calculator actually. Now, how do I put it in my calculator? How do I use my calculator to graph this function? Okay, let me go to my calculator, go to the first one, and turn my calculator on, clear. Go to y equals, clear all the things in the function. All right, and Okay, so I want to put the first piece of function and then the condition. First piece of function and the condition in the equation. So the first piece of function is, and all of them should be in a line. So I'm going to use parentheses for the first piece. And I have x minus 3, and close parentheses, and open another parenthesis. And I use x is less than or equal to. So I put x less than or equal to. Where do I see inequality? I will see inequality in, let's go to math, second math. You see where it says test. So I'm going to test. Second math, you see test. And here I see inequalities. I will look for which one is less than or equal to. Which one is number 6 is less than or equal to. So I'll select number 6. And then what is it less than or equal to 5? Then I'll close parentheses. There are 2 pieces. So I'm going to join all the pieces. So I say plus, and then parentheses, I can just put 2 there. There is only one number in that equation. And then I close it. And then I open another parenthesis and I put the condition. And the condition says x is greater than 5. So x, and I will look for the inequality. Remember, last time we went to test. So second math. So you go to math, test is under math. And I look for the inequality. The inequality here says less than 5. So if I look to test, I see that less than is number 3. So I'll select 3. And then remember, you put in, don't forget the number. The number is 5. Okay, we have to make sure that it's greater than 5. Close parentheses. So I'm ready to graph. Before I graph, I will check, even if you made a mistake in the one you did analytically, when you are doing it by graph and you put everything correctly, it will show you the actual graph. So I want to make sure we choose the right function on the graph. So I'll go to my windows and see if my windows are okay. Yeah, my windows are okay. So I'm ready to graph. So I'm ready to graph. Let me graph the piecewise defined function. See? Okay, so that is the kind of thing. Remember, you are using a calculator. So the calculator will not show you the arrows, but kind of you get it. So the one that, you see, your calculator is more accurate. So the one that is more accurate here is actually A. So let's do B again. Let's do B. Let's do B. So now you can graph a piecewise defined function by hand and with your calculator. So, and if you put everything, all the conditions correctly, your calculator will give you a sketch that is almost the same, but you are the human being behind the calculator. So we require the conditions, the arrows, the point where the holes. If there is a hole, it means that the point is not included, where the extremes are unbounded. Okay, so let's graph another one. Let's graph another one. And then if there are 3 pieces, we wait for that. So number 6, we're going to graph another piecewise defined function. So if you can graph it with calculator, that's good. And whenever you do it by hand, you check your work. If you do it analytically, you check your work with your graphing calculator. Okay, this is a binomial, so I like to close my binomials with parentheses. So -2 minus x is the first binomial. Remember, this is, you want to actually start with parentheses, negative in parentheses, because it's the first one. So -2 minus, this time, this minus is not in parentheses, this two, because if you put the wrong minus there, your calculator will tell you to quit. And then you choose x. This is x. Then close the parentheses. You have put in the first piece of the piecewise defined function. So you have to also put the condition of the first piece. What is the condition? I will open a parenthesis. The condition says x is less than or equal to 1. So x is right here. Where do I see the condition? Second, math. You see the condition on test. And the condition says less than or equal to 1. So I will select less than or equal to. Less than or equal to is number 6 of the test. Select that. And then the number at the right is 1. Then close the parentheses. And you're not done yet because there are 2 pieces. If there are 3 pieces, you have to put in all the pieces. If the inequality is a compound inequality, you have to put all of them in. Okay, so the next thing I want to do is to add and put in the second piece. The second piece is a binomial again. I open a parenthesis, put in the binomial, -2 plus 2x. Then close the parentheses. But I have not put in the condition which says x is greater than 1. So there should be a parenthesis for the condition. So I'm ready to put in the condition. It says x greater than 1. So x. And then go to test again and find where greater is. So I've done it several times. I know you will be able to find it. And greater is number 3. Select greater. Don't forget to put the number at the extreme. So I will just put in 1. Then close the parentheses. If you eyeball your calculator function number 1, you can actually check what you typed in because human beings make mistakes. And by the way, I just want to let you know that graphing a piecewise defined function is in the test. So just know you should be able to do it. If you're comfortable doing it by hand, analytically, then you don't worry about the calculator. But if you're more comfortable graphing with calculator, that's okay. All right, so now I have put in the first piece of the function and its condition plus the second piece and the condition. I'm ready to graph. I think my window is still okay. So I'm going to graph and see what happens. Check if I'm given some graphs to choose from. So you see, this is a discontinuous function. Some piecewise defined function is a discontinuous function. You see, this one is showing that the function is broken somewhere. Okay, and you should be the one choosing where there is a hole in the graph. So in this graph, there's a hole. This is an example of a discontinuous function like we talked about the other day. So because the second equation has only greater than, then here, which is the second equation, the hole should be here. and this point should be closed. Don't forget to show the direction of the lines. You use arrows to show the direction. Use arrows. You cannot leave your answer. That is why you are the one operating the calculator. So you cannot leave your answer like that if you're told to graph it. You must draw the graph, show the holes, show the close point. If it is less than or equal to, it is closed. If it is greater than or equal to, it is closed. If it's only less than, it is a hole, it's open. And the arrow must be going to where the inequality is going. So this has arrow to the right, and this has arrow to the left. This one, your calculator drew, if you put it in your answer sheet like this, you will not get the grade. So you should know to show the direction of the graph. Okay. And we will choose, if we're lucky to have graphs given to us, we will choose the one that looks like a graph. So let me pull up my calculator again and choose which one is like my graphs. This is what I'm saying. I am going to get my calculator back again. So the graph I drew, one has a hole in it. So this is less than or equal to, therefore this is closed. The arrow going to the right is closed. So I better choose, and everybody should know that it is at 1. So, and then the other one is going to the right. So there is no transformation in this graph. So you better choose, make sure you choose the right graph. Is there any questions so far about graphing a piecewise defined function? Anybody? You can unmute yourself and speak. Anybody?
No, ma'am.
Remember? Yes, go ahead.
Oh, I said no, ma'am.
Okay, okay. All right. So you should be able to graph a piecewise defined function in the test. And I'm going to grab this one and send it to you as I'll send this one to you. I'll record it that way because this is 3 pieces. So I'm going to record this one and send it to you. You will see that it's a recorded. That way you will not forget it. And so those who are not here today will not forget it. Okay, so the next thing we want to do now is go to, this is actually section 2.5. So this is section 2.5. The most important thing here is to be able to graph a piecewise defined function. It can be a cubic function. It can be a quadratic function. Just know it doesn't really have, it's not supposed to be linear all the time. Note that this is quadratic. So even if it's quadratic, you just need to obey the conditions at the right. All right. So so what we're going to do now is, so the rest of this piecewise defined functions, I'll make sure that the ones you will get will not be too hard, but you will still get something. Well, suppose you're told to graph a question, something like this. It's an integer. So if you're told to graph this, you just have to get where integer is and put in x plus 1. And it means that, see, they're all broken lines. They're also called discontinuous functions. If you graph the integer and it has closed dots on the other end, then it means that it is from left to right. It's closed at the left. You can use that. But if you are, I want you to note, but first of all, that this is a linear function and the coefficient of x is positive. So you are expecting an integer function that is rising to the right. So by mere looking at this graph, you already mark it out. You mark it out because it should not be a graph rising to the left, falling to the left. Okay. And the transformation inside that graph is 1 unit to the right. So if you can eyeball the transformation and the coefficient of x, you won't have any problem. And that means that the graph should not touch the origin. So it's going to go to 1 unit to 1 unit to the left. So let's see where if it is positive, you're adding 1 unit to the right. So if it's negative, and so we can go to where the graph is and make sure it is shifted. If it is negative, it is shifted to the right. If it is positive, it's shifted to the left. If the transformation is negative, shifted to the right. If the transformation is positive, shifted to the left. Okay, so you should be able to know which one is shifted to the left, by the way. You know that your answer cannot be this because it's not shifted to the left. So you can do the elimination. Sometimes if you know what the function is, you don't really have to graph it. You don't really have to graph it if you know what the function is saying. Okay, you can do the elimination by eyeballing the function. Okay, so these are also, you just need to get 2 of them. That's not going to be a lot of them. Okay, so what each of them as answers, well, this, I'm showing you what is the homework for tonight. So I'll actually go to homework for 2.6. And then after 2.6, we go to practice test. Remember, we have a test. And we may not meet again. We will not meet again until that Monday. But I will log in on Monday morning to see if anybody is confused. I want to say this again. The test will be in my lab maths. You can do it online. The test can be done online. And for those of you working, I know I'm recording this, so they won't say they're going to, you cannot say you went to work, you didn't hear me. I'm recording it. If you're going to work, the test will open in the morning by 6 a.m. and close by midnight. You have 2 attempts. I will email you in the announcement the password. If you don't have the password, you cannot take the test. The password will be in the announcement, class announcement. So everybody must take the test. You cannot say you went to work. If you don't take the test, you get a 0. And remember, final exam can only replace 1 test. If you miss 2 tests, then 1 will be 0. Okay. And this is a fast track class. So we take a test every 1 week. So our first test will be on the 20th. We started on the 13th. Okay, so the next place we're going is homework 2.6. So let me pull that up. Homework, what do we see there? Okay, we will see what is called difference quotient. So we're going to talk about difference quotient in section 2.6. You need to know what I'm talking about today about difference quotient because it's actually the beginning of calculus 1. If you know the difference quotient, you can take limits. So I am going to 2.6. So this is 2.6. Remember that the test contains section 1.2 to 2.6. So this is the last section in the test. Remember, you can use your calculator. Anywhere you can use your calculator, go ahead. Now, let's do number 1 by hand. And after we do it by hand, we do it by calculator. And by the way, this is always too long, so I'm going to shorten the tape now by going to my, I'm just going to go here and